This video will illustrate the role of the data link layer in networking. You'll work with many specific Layer 2 protocols, and these concepts underlie them all. For network layer packets to be transported from source host to destination host, they must traverse different physical networks. These networks can consist of different types of physical media, such as copper wires, microwaves, optical fibers, and satellite links. Network layer packets do not have a way to directly access these different media. It is the role of the data link layer to prepare network layer packets for transmission and to control access to the physical media. The data link layer exists as a connecting layer between the software processes of the layers above it and the physical layer below it. It relieves the upper layers from the responsibility of putting data on the network and receiving data from the network. The data link layer prepares a network layer packet for transport across the local media by encapsulating it with a header and a trailer to create its own protocol data unit, or PDU. The data link layer PDU is called a frame. The frame header contains the control information for the specific logical topology and media used. Frame control information is unique to each type of protocol, but typical frame header fields begin with the start frame, which tells devices along the way that a frame is coming. Next is the address portion, which is the data link layer source and destination address. Finally, the type length field is an option that states the kind of data or the length of the frame. Depending on the protocol being used, additional fields may also be present. The trailer is used to determine if the frame arrived with any errors. Error detection is accomplished by having the source host calculate a logical or mathematical sequence based on the content of the frame and placing that sequence in the frame check sequence field. The destination host will calculate its own check sequence and compare it to the values stored in this field. If these values do not match, then there was an error and the frame is discarded. The stop frame is optional and is used when the length field is not used. As an IP packet travels from source to destination, it will cross devices using different media types. The data link layer is not only responsible for the initial encapsulation of the packet, but also for decapsulating, processing, and encapsulating it into a new data link frame as it traverses the media from one device to another. In this graphic, you can see that the Layer 2 media changes from device to device, and so does the frame type used to travel over the links. To support a wide variety of network functions, the data link layer is divided into two sublayers. The upper sublayer is called the logical link control, and the lower sublayer is called media access control. Separating the data link layer into sublayers allows for one type of frame defined by the upper layer, for example an Ethernet frame, to access different types of media defined by the lower layer, such as a Wi-Fi network and a wired network. The logical link control sublayer places information in the frame that identifies which network layer protocol is being used for the frame. This information allows multiple Layer 3 protocols to utilize the same network interface and media. The network interface card, or NIC, in each device has both software and hardware components that provide Layer 2 services. Let's look more closely at the media access control sublayer, which regulates the placement of data frames onto the media. It also provides addressing and delimiting of data according to the physical signaling requirements of the medium. Media access control is the equivalent of traffic rules that regulate the entrance of motor vehicles onto a roadway. In controlled access networks, such as some wireless LANs, only one device can transmit at a time. The media access control layer follows the rules necessary to put traffic onto this type of network. In contention-based networks, such as Ethernet, the rules for putting data onto the network are different, but the media access control sublayer assures this happens correctly. In a TCP/IP network, all Layer 2 protocols work with the Internet protocol at Layer 3. However, the actual Layer 2 protocol used depends on the logical topology of the network and the implementation of the physical layer. Layer 2 protocols that will be covered in CCNA courses include Ethernet, Point-to-Point Protocol, or PPP, High-Level Data Link Control, or HDLC, Frame Relay, and Asynchronous Transfer Mode, or ATM. You have seen that to support our ability to live, work, play, and learn over the Internet, the OSI model divides the functions of the data link layer into sublayers. One, the LLC, prepares network layer packets for transmission, and the other, Media Access Control, as the name suggests, controls access to the physical media. You will learn details of some common Layer 2 protocols as you continue your studies of networking.